Hi and welcome to my maths class. Today we're doing a revision on all of the grade 11 trig graphs. Now, in order to know your grade 11 trig graphs, you need to be familiar with your grade 10 graphs. So before you continue with this video, if you are not familiar with your grade 10 work, please go to the summary videos of graphs and look at the trig graphs for grade 10. Now, in grade 11, you mainly concentrate on the effects of x. In grade 10, when you were changing the drawings, you always changed y. But in grade 11, our emphasis is on x. Now, when you're drawing the graph, the mother graphs are still the same. What happens to this area where we're affecting it next to the theta is it always multiplies or divides with x. When we're affecting it and it is a plus or minus, in other words, it's a break in the term with theta, then we are going to add or subtract with x. Now, keeping in mind from all your previous works and your previous functions, you know that usually x always works opposite. So if the relationship in the graph is multiplication, then you would divide. If the relationship is addition, then you would subtract. Now, if you take the graph, what does it mean when I say multiply or divide? If I give you an equation, let's say I give you a graph, y is equal to 3 sin theta plus 30. Now, from your previous work, from your grade 10 work, you would know that the 3 in front affects your y, and what it does with your y, it multiplies it by 3. So when you're starting all graphs, the first thing you have to do is you have to have the mother graph. Now, you should know the mother graph already. Now, we have our x and y, but because we are doing grade 11 work, they tend to go into the negative as well as the positive. So you're not just going to go 0, 90, 180, 270, 360. You're going to also go into the negative. When you look at the mother graph, remember your board mass is important. You must know what adjustment we're making and is it addition or subtraction. Now, from your grade 10 work, we know that the 3 is an adjustment on y. So you're going to multiply the y by 3. So we multiply everything by 3. And we have 0, 3, 0, minus 3, 0, 3, 0, minus 3, and 0. Now, look at the adjustment to the x. It is theta plus 30 degrees. Remember, I told you that x always works opposite. So what are we going to do? We are going to subtract 30. So what are we plotting? We're plotting minus 390 and 0. So what we now plot is, we plot these coordinates with the following. We are not using the mother graph to plot. So let us plot it. The norm is they would usually give you a restriction. Most commonly in grade 11, it tends to be from minus 180 to 180. But if they tell you minus 360 to 360, then when you are plotting, because the restriction is minus 360 to 360, you cannot plot that specific point. So you have to press in your calculator 3 sin, and then you are looking specifically for 360 degrees. So you say 360 plus 30 close brackets equals to, and that will give you 1.5. So what are you plotting? You're going to plot minus 360 and 1.5. Now remember, that specific point, you got it on your calculator. The rest you're going to follow from your mother graph. What are we plotting next? Minus 303. So minus 303. And then we've got minus 210 and 0. Then we've got minus 120 and minus 3. All I'm doing is I'm following the coordinates that you had calculated on your table. So you're going to do each one and then you'll see, but you don't have a 360 point. Yet the restriction says minus 360 to 360. So that specific point you put in your calculator. And when you press it, you simply press 3 sin. What coordinate are we looking for? We're looking at 360 degrees. So you press 360 plus 30 close brackets equals. So we get 1.5 again. Now it's simply a matter of joining the dots. So when you're doing the graph, you need to be able to answer questions like the domain, the range, the period, the amplitude. Now, domain and range is usually what is drawn. What can you see on the drawing? So for the domain, if you look, they told you to draw from minus 360 to 360. The range, if you look at the range, what is the lowest? The lowest point is minus 3. And what is the highest? The highest point is 3. So we're looking at minus 3 and 3. Remember, when you are answering these questions, you have to go from the lowest to the highest. Now, why are we putting it in square brackets? Because it is including those points. Usually with an asymptote, like in a trig graph, you would get a round bracket. Now, what is the period? The period is the entire cycle. How long does it take for the entire cycle to complete itself? Now, usually the period of a standard sine graph is 360 degrees. If there is no adjustment between the sine and the theta, then it usually stays 360 degrees. But if you want to look on the graph, if you look, the graph is starting. If you take any starting point, let's take here because this looks comfortable. It's starting here and then it's ending here. Now, what is the degrees between those 2 points? Now, you see, from minus 210 to 150. So, if you take 210 plus 150, you will get 360, because look, from minus 210 to 0 is 210 degrees. From 0 to 150 is 150 degrees. And if you add it, it would equal to 360 degrees. But an easier way to look is that a standard sine graph is 360 degrees. Unless you adjust by a mean of multiplication or division with the theta that is next to the ratio, then it changes. Otherwise, it usually stays the same. So 360 degrees is your period. What is the amplitude? Now, amplitude, you usually take the highest point minus the lowest point divided by 2, provided there is an entire graph that is drawn. Remember, if I give you half the graph, let's say we only drew a piece of the graph. So we drew from 0 degrees till maybe 180 degrees. Now, if you look, the highest point would have been 3 and the lowest point would have been around here, which we could say 1. That is not a fair opinion when you are doing amplitude. If you're going to take high minus low divided by 2, you must ensure that it is an entire graph that you can see. Otherwise, the wiser thing to do is to look at the number in front of the ratio. Now, if you look at the number in front of the ratio here, it is 3, and the amplitude of this graph is equal to 3. So usually the period and the amplitude, it is better to get it from the equation. Try and get them from the equation, it is usually safer. Right? So if they give you the equation, try and get the period and amplitude from the equation. Now, the way we had done the adjustment for a sine graph is exactly how we would do it for a cos or a tan. We're going to do different styles for the tan or cos so you can see how we adjust the graphs accordingly. What you had learned is that when we're doing an adjustment, we had done this specific example where we got x plus p. Then the adjustment is plus or minus, and I told you x is usually opposite. Right, what we did was we worked with the mother graph, then we did the required adjustments, and you plot. Now let us try one where we have a b theta, but I'm not going to do a sine, I'm going to do a tan because the methods are all the same. All that changes is the mother graph. If you remember your mother graph, then you would be fine. Alright, let us take the following graph. Y is equal to tan 2 theta plus 1. Now the plus 1 is a grade 10 adjustment, and what we're doing is to the y we are adding a 1. Now remember, with asymptotes, you don't do anything because they are already undefined. So what do we have? We have 1, 2, and then we have an asymptote, 0, 1, 2, asymptote, 0, 1. Now let's look at the 2. What do we have to do? Because it is multiplying with theta, we are going to divide all of it by 2. So we have minus 90 minus 67,5 minus 45 minus 22,5. 0, 22,5, 45, 67,5 and 90. Now let us plot the graph. If you look, your asymptote now, what are we using? Which coordinates? We're going to use the adjusted coordinates. So our asymptotes are now on minus 45 and on 45. Then what are we plotting? We got minus 90 and 1, and then we have minus 67,5 and 2. That would be between this, and so what happens to the graph is it is going like this. Then we have minus 22,5 and 0. We have 0 and 1. And then we have 22,5 and 2. So if you look from your original tan graph, you know the graph goes like this. So knowing the pattern, because the pattern maintains itself, but because you lifted the original graph from 1, instead of being at 0, 0, we went up 1, grade 10 work. If you're not familiar with that, you need to go over your videos of grade 10 to understand this. So we know it should have been on 0, but it went up 1. Now we have 67,5 and 0, and we have 90. We have 67,5 and 0, and we have 90 and 1. Now if you know your pattern of the trig graph, you can see it's exactly the same as the trig graph. But instead of it being over 180 and minus 180, what are we doing? We squashed it. So we made it smaller. Now if you look at this, if they asked you to continue, then you know the graph is no longer, if you take one complete period, it is running from year to year. So what is the distance there? The distance there is 90 degrees, which means that if you were to continue, the next asymptote would be on minus 35 because it is 90 degrees. Then it would continue, and this way here also it would be on 135 and it would continue. Because the graphs repeat itself. If you wanted to continue here, you know it's going to be on minus 180 and it's going to go up. Here it will be on 157,5 and 180. But remember, these other points, if you continued with the table, you would get them because the pattern keeps on repeating itself. It keeps on going again. So if you looked, I had an asymptote, then I had a line on the 0, then I had a 90 and a 1, then I had a 2. So it's again asymptote, 0, 1, and then obviously the next one would have been 2. If you go this way, it was asymptote, 2, 1, 0, asymptote, 2, 1, 0, asymptote, and then 2, 1, and if you continued, 0. Now, what are the questions that they would ask you? They would ask you things like, what is the domain? What is the range? Now, as I told you when we were doing the sine graph, domain and range, you're going to look at your graph. Okay, now, if you looked at the domain and the range, domain is usually what they tell you to draw. So in this case, we know it's moving from minus 180 to 180. So the domain is minus 180 to 180. If you look at the range, it's going from infinity, negative infinity to infinity. So if I wanted to do the domain and range for this trig graph, the domain would have been minus 180 to 180. Remember, there is no restrictions in your domain. You drew from minus 180 to 180. So even though you have an asymptote, you don't put there that it cannot equal to this. Now the range, minus infinity to infinity. But look, I have a round bracket because infinities are always with a round bracket. Then they would ask you the period. Now we've discussed this. You can see it's moving from minus 45 to 45, which gives you a total of 90. Now look at what we did. We know it is tan 2 theta plus 1. If you look at this, the original of a tan is 180 degrees. Then we are going to divide it by the 2 because the relationship is multiply. And if you divide it by 2, look at what you get, 90. So to get the period, look at the question. You know the originals. If you take the original, you see the adjustment that is specifically near theta, and that would be your period. Then they would ask you the amplitude. With a tan graph, there is no amplitude. Now let us go over this specific period. When you are working with the period, we know that we have y is equal to, let's take any ratio, b theta. What you're going to do when we come to period is, you're going to take the original and you are going to divide it by b. So if I was to give you cos 3 theta, the original cos graph is a period of 360 degrees. Remember, that is from your mother graph. What am I going to do? I am going to divide it by 3, which would immediately tell me that the period of this graph is 120 degrees. It doesn't matter if I go and I add numbers in front or after it. The number that affects the period is the one that is immediately next to the ratio. Let's say I gave you cos theta over 3. Now what is the relationship? The relationship is divide. The mother graph is 360 degrees. I'm going to do the opposite, so I'm going to times it by 3. Or if you want to use this rule where it says original divided by b, what is the b? It is actually a third theta. So what you're going to do is, if you say 360 times 3, you're going to get 1080, or you could say 360 divided by a third, which will also give you 1080. So when you're working with period, remember it's original divided by b. Thank you for watching.